Good morning, grade 9s. Today what we're going to do is we're going to look at lesson 8.2, which is the properties of chords in a circle. Now, these properties are very, very important for you to understand and to memorize because they are going to give you the tools that you need in order to solve the questions that you're going to be given. So I know the first page you've got right now, you've got a whole bunch of stuff here and it says take another piece of paper and do some folding and stuff. I'm not going to have you do that. What I'm going to do is I'm just going to show you rather than have you do all that stuff. So we're going to use this little circle here and you can copy onto it the stuff that I'm going to do. So it says construct a large circle marking the center O. So there's my center, there's my O, there's my large circle. It says choose 2 points on the circle so that when you join the 2 lines, they do not go through the center. So you could have put lines anywhere you want, but they cannot go through the center here. Mark these points as point A and point B inside the circle, and then join them with a line. So that's describing what you have to do this here part of the exercise. Now it says cut the circle out. Well, I don't want you ruining your notes, so don't do that. It says fold your circle along the line segment so that point A and point B overlay each other. So you fold this over to this side, and you want this line here to line up on itself such that A and B both match this point right here. And then you fold it and you crease it. Okay. And it says mark C where the actual crease is. So when you crease it, it's going to look, you're going to have a crease right there. Now remember, a crease is just a folding line. And it says to mark this as point C. So now we've got AC and we've got CB, 2 line segments. I've got a line right here. So what do you notice about the angles at C? Well, you should have noticed the angle at C, these are 90 degrees. Okay. Now what about AC and BC? Well, if you measure these, you'll find out that they are exactly the same. So let's just grab our tools here. Okay, so when you measure it, you'll notice that from A to C, it's kind of difficult to see here, but let's take and put a magic line here. So you see A to C right here. You notice that it's almost perfectly at 2. And you look over here, this is almost perfectly at 4. They are equal. Now, to show something's equal, we just take a mark here and we put a mark on each one and we call these prime marks. Okay, so that is equal to that. So what did we learn here? We learned that if you take and bisect this by folding it over, you get a 90-degree angle there. And this here is 90 degrees. Now let's try another one here. What if you put 2 more points on here? So I'm going to try and put one here and put one over here. We're going to draw a line joining it, just like before. All right. Now, if you fold this, here's what's going to happen. You're going to get a line that goes from here straight down, and it bisects that at 90 degrees also. So this is what you would have found out if you did this. That would be 90 degrees. You'll also have noticed that that line there and that line there are equal. So you notice for B and C here, it says here, what do you notice about the line segments AC and BC? That's what this one is here, AC and BC. You notice that they're equal. Place 2 more on here and call these E and F. And I think they said to call, I don't know, maybe this is supposed to be a D. I'm not sure if I put that there on the next page. I guess it's not supposed to be a D, it's supposed to be a G. What do you notice about these angles? They're 90 degrees. And what do you notice about EG and GF, the 2 line segments? They are equal. So do you think this works for all line segments in a circle? And the answer to that is yes. So what have we discovered here? This is kind of like the summary of everything. All right? If this here is perpendicular, right, you get a 90-degree angle. That's true. If you cut this in half, you'll get a crease mark that goes down here, and AC equals CB. That's right up there. These are 2 equal lengths, and this A to B is called a chord. This is the fundamental thing we have to understand, because no matter what happens now, we can take and create 90-degree angles, right, all over the place here. So here's one here, 90-degree angle. There's a 90-degree angle, right? If we wanted to, we could run down the bisector right here, and we could make an angle here, which means 90 here, and also another 90 here. So we can make 4 triangles there that are the possibilities that you may have to use to solve this question. So let's go on and talk about each one of the chord properties individually. There are 3 of them, and they all revolve around the fact that the center and the 2 segments are equal and it's 90 degrees. So this is the first one. It says if you start with and you draw a perpendicular line from the center of a circle to a chord. So if you draw this right here, perpendicular, this is what will happen. It will divide this chord into 2 equal points. Now here's your chord, but it's going to divide it. If you make this a 90-degree angle, right, then it will divide this and this in half. And your center is always called O. So starting with a 90-degree angle, you get 2 equal chords. Property 2 says, well, what if you go backwards? What if you have a chord and you create a bisector from this chord, right? So it goes outwards from this direction. So if you make a bisector from this, right, it means it's going to go through the midpoint. It has to. That's the chord property. Any bisector of this goes through the midpoint. And that's very important because the actual program that you're going to get later on is going to say, okay, if you got this happening, what do you know? Well, if it goes through here, right, you make a perpendicular bisector. Now that's 90, which now means, guess what? We have Pythagorean theorem, and we can do all these wonderful right angle triangles. The third one. Now I'm going through these quickly, but we'll start talking about how to use them later. A line that joins the center to the midpoint. So if you start with the center, and you know this midpoint right here, and you draw a line from here to there, guess what's going to happen? This is going to be a 90-degree angle. So these 2 here, obviously this is your chord. Right? You find the midpoint, divide it by 2, and you know that point. If you draw a line up, you're going to get a 90-degree angle. Now again, why is that important? Well, guess what we get when we do that? A whole bunch of right angle triangles for our Pythagorean theorem. So let's use some of these properties to solve an actual question. Point O is the center of a circle. That's given. Let's continue. The line segment OC, this one right here, O to C, it says that it bisects it. Now if you bisect AB, now bisector means cut it exactly in half, then we know that this line right here and this line right here are now equal. But more importantly, we also know something. If these 2 are bisected and the bisector goes through 0, we know that that is 90 degrees. Okay, so the problem goes on and says, what can you tell me about this stuff? Well, we know that AC and CB, they are equal. And that's because of chord property 1. It also, because we go from a perpendicular line out through the center, we know that angle at OCA and OCB, that's 90 degrees. So if I know that A is 41, I want you to pause the recording and I want you to find the value of Y. So pause the recording and do that first. Okay, now here's the trick on this one. This is the key. What do you notice about this line, which goes from here to there? What is that called? All right, that's called a radius. Now, if that's a radius because it goes from the center out to the circle, that means that this is the radius also. And since the 2 radii, that's plural for radius, since these 2 are equal, that forms an isosceles triangle. Now we know from isosceles triangle that they have 2 equal sides, but more importantly, we know that the distance, the angle right here and the angle right there are equal. So we know this is 41 degrees. It tells us that right there. So that means that Y is 41 41 degrees. And that's what this description says here. So stop the recording and copy that down. Okay, now how can you find the angle at x? So I'm just going to take all this stuff out of here for a second just so we don't have to mess with it, okay? Here is x right there. This is what I want to find. I want to find this angle right there. So I want you to pause the recording and I want you to find angle x. Right, so we know that this is 90. If this is 90 and this is 41, we know that the triangle here has all the interior angles have to add up to 180 degrees. That's one of the fundamental properties of a triangle. So if this is a 180-degree triangle internal angles, then to find x, you're going to take 180, we can subtract the 90, and we can subtract the 41. Right? So since triangle ACO is a right triangle from chord property 2, we know that because we divide, when you put a bisector down, that makes this here a 90-degree angle. That we can use the 41 degrees and the 90 and the fact that the internal triangle angles are 180 to find it. So this is what it looks like. Angle Y is 180 degrees. Take away the 90, take away the 41. So that leaves us with Y is 49. Now, something else you might want to realize is that because this is a right triangle, they share this side, they share the radii. They also know that these two are equal because this is a bisector. You should be able to look at this and go, oh, well, if the angle down here, Y is 49, that means this angle here is also 49 degrees. These are actually what we refer to as congruent triangles, which means they're perfect matches. If you folded this over, OAC would match up with OBC. All right, turn the page. Okay, so here is our next one. It says point O is the center of the circle. So there we go, we're at point O. A line segment OF, all right, so from O to F right there, bisects the chord GH. So stop right there. The word bisect means cut it in half. That means that you're cutting GH in half. That means that this here, those two sides are equal, those two line segments. Okay. Now it says here the GOF is 53 degrees, so we know this angle is 53 degrees. Now we know that since they share this angle and these are both radii, and these two sides here are equal, you could just match it up. If that's 53, this here is also 53. I can't write very well, right? And we know that if this is x, this also is going to be exact same angle x. So the angle x, right, which is over here at G, is going to be 180 degrees. And we're going to take away, remember this is a perpendicular bisector, so we know that's 90 degrees. 180, take away the 90, and take away the 53, which we were just given, means that x is 37 degrees. Now, if this is 37, that is also 37. All right. Now, taking and erasing some stuff here to get out of the way, what do you think angle Y is going to be? Well, we talked about this already. Angle Y, which is FOG, is 53. Sorry, FOG is 53, but we know that these two are congruent triangles. They're perfect matches. That means that angle Y is also 53. So we'll copy this down, and I'll give you a couple of seconds. Pause the recording and do that. Okay, so since the triangle GHO, so it says GHO, this triangle that names the whole triangle, is an isosceles triangle because we have this radii, these two radii right here. These are equal. And we know from this being bisected that those two are equal, right? And these two share an side, so these are congruent triangles. Okay, so it says here with OGO and OH equal, the angle at G and H are equal. So what it's saying is that this is an isosceles triangle, that angle and that angle have to be equal. And we know that because that's the property of an isosceles triangle. The two sides are equal and the two end angles are equal. So using the sum of the angles in a triangle, Y can be calculated quite simply by taking and doing the calculation here. Now, it's pretty straightforward because we know that this is 53, and that means this is 53. So the calculation for this, angle right there is actually not really even needed because you can look at it. So in this kind of a situation, you could answer the question with an explanation saying that these two angles here, internal angles, are equal because GFO and HFO are congruent triangles. You could just state that, and I would go, yeah, that means this got to be 53. So you could use the math here, or you could use an explanation, but also don't forget to tell me that angle Y is 53 degrees. Let's take a look at our next one. Using Pythagorean theorem in a circle. Now, we talked about all these right angle triangles before, and I kept drawing them in for you. So let's take a look at what we got happening here. This one looks complicated, but there's a key to it. And the key revolves around the fact that the WX is a diameter, and it is 102 millimeters. So that means that I've got from here down to here, it says that YZ is a chord, and it's 30 millimeters from the center of the circle. So from here to here is 30 millimeters. Now, here's something you have to understand. The shortest distance between a point and that line means this is going to be 90 degrees, right? Because this is a chord. It says, what is the length of YZ? So how long is this to the nearest tenth? So we have to add a dimension to this circle. So I want you to draw on that the missing parts. And just so pause the recording and draw that on. All right. So taking a look at this, there is a piece of information that we can put in here. And that piece of information is there's a radius from there to there, and there's a radius from there to there. Now to make it easier, I'm just going to be using just the one triangle. We also know that this here and this here are equal. So the length OY is a radius. So it is half the diameter. So if this is the whole distance across, then the distance from here to here is going to be half of 102, which means that OY is going to be 51 millimeters. Now, having done that, that means that we have this information now on our diagram. So we have to solve this now to find YZ. I want the whole distance across here, but I can't do that directly. I have to kind of do it in another way. I need to find out what this length here is. What is that length right there? Because if I can find this length, then I know it's going to be the same as this length right here. So all I got to do is take these two things, add them together, and that will give us our answer. But to get this, I've got to do Pythagorean theorem. Now taking a look at our right triangle, this is my hypotenuse, and that means this is A and this is B, or the other way around, doesn't matter. So I can take that information and I can create a right angle triangle, and then I can solve it using Pythagorean theorem to find out what, in this case, I've labeled it as B. Okay, so pause the recording and copy your notes down. Okay, so moving on to the next page, here's our calculation. So I used L here again. It doesn't matter. Length is H. It can be an H and L or whatever. So A squared is equal to L squared minus B squared. That's our Pythagorean theorem. Remember, I'm finding, I guess when I go back here, I've changed my numbers. I should go back down here and fix it so you know what's going on here. What I did here is in my first calculation, my first stuff, I switched these around so that I'm finding B here. So here's A down here, here's B here, and there's my H. In fact, I called this L in my notes. Okay, so having that, let's go on to our next part right down here. We know that A squared is what I want to find. That's the bottom of that triangle, right? Looks like this. This is A, this is B, and this is H, or L, I guess it is. This is 51, right? And if you look back, I think that the other one was 33, right? Yeah, 33. So this is 33. Now we're in millimeters here. So let's take a look at our Pythagorean theorem. Fill out your formula. Now we put the numbers in. A squared is going to be equal to the hypotenuse squared, so that's 51 times 51. And it's going to subtract B squared, which is 33 squared. So 51 squared is 2,601. 33 squared is 1,089. Subtracting that, you get 1,512. Now to go from an a squared to an a, you've got to square root it. So the square root of a squared is a, and the square root of 1,512 is 38.88444, etc. Now in your instructions, if you go back here, it was very clear, nearest tenth. You always got to remember that. So if that's the case, we have to round that off. Right? Now, there's something here we have to think about first, okay? Remember, we want to find the distance all the way across, right? Now, we know we've got to go to the nearest tenth, but you round off after. We always use this in our calculations. So take this and multiply it by 2 first before you round it off. That's the rule we always use. So this becomes 77.8 millimeters. Oops, that didn't work well. All right, there we go. Here's our next example. Now it says here that point O is the center of the circle. What is the length of x to the nearest tenth? Now again, you look at this and you say, okay, if this is 44 from A to B, and this here, you see the prime mark there? That means that AE and EB are equal. So that means that this one right here is going to have to be 22. Oop, number. And this one here is going to be 22 because that's 44 divided by 2. Right? So now I've got the two sides here. They're all taken care of. Now I know that this is 22. I know this is x. It's an unknown. So I have to form a right angle triangle. Now we know from our right angle triangles from before, to form it, all you have to do is go from the center and go to here. That gives us AO. Now that's important because this is a radius. And if you look here, this is a radius and this is a radius. This here is the diameter. So I want to divide that by 2. 72 divided by 2 means that this is going to be 36. And this over here, if I was drawing it that way, that would also be 36. So that's 36 for that radius. This is 36, and down here, that's 36. But we're only working with this triangle here. Now, if this goes straight in here and bisects that, it tells us that this angle right there is 90 degrees. So I now have a right angle triangle with 36, 22, and the unknown x. So pause the recording and copy that down. All right, let's go to the next page. So let's take and solve this. Our first step is a squared is equal to L squared minus B squared. And we now can substitute it in. We know that the L squared, the longest side of my triangle, is 36. My B is 22. And I'm trying to find A squared, which is our X value. Squaring 36, you get 1,296. Squaring 22, you get 484. So that's 22 times 22. Do the subtraction, you get 812. Do the square root, because to get from a squared to an a, you square root. So whatever you do to one side, you have to do to the other. The square root of 812 is 28.5 millimeters. So there's your answer. So the length of EO is 28.5 millimeters. All right, now, every year in the achievement test, they have a question like this. Sometimes it's water in a pipe. Sometimes they say this is a big underpass, which is in a circle, and this is all concrete pathway, and they want to know how wide the pathway is. Sometimes they want to know how high it is from the ground to the top. All of these are variations on the same question, and they always start out with the same thing. Here's your pipe. Here's the level that you want to work with, and this one we're working with here is water. So it says a horizontal pipe has a cross-sectional area shown below with the center O. Its radius is 85 centimeters. So knowing this 85 centimeters, there's our first one right there, 85. So knowing that, we can take and go on to the next part. The water can only fill half the pipe or less. Now remember, point O is at the halfway point. The surface of the water is 140 centimeters wide at this point. So if that's 140, we know that this is going perpendicular straight down. We know that this one right here and this one here are equal. If that's the case, then we know that this here, if this is if this is going to be 140, that means that this one right here is 70, and this one over here is also 70. You see how I'm piecing together all the pieces before I even begin? I want to have as much information as I can in order to solve this. All right, so we know those are 70. We know that this is divided in half. We know that's a perpendicular bisector. So that means that this angle right here is 90. And so is this one right here on the D. Now it says the question here, determine the depth of the water. Well, I don't know what this is here. I can't figure that out. But what I can figure out is I can figure out what this is. Right? Once I know what that is, I know that OC is a radius, which is 85. So if I want to find out OD, the depth of water, I'm going to take 85 and I'm going to subtract the line length of OD from it. So I need to find out what this is. So there's my L, or my C, or my H, whatever we want to call it, and this would be A or B, and this would be A or B, depending on which way you wish. So I've got all the information I need now. So pause the recording and copy that information down. All right, now let's go to the next page, and the next page is where I'm going to put in all of the stuff on your solving. First thing we need to do is to solve for a squared is equal to L squared minus B squared. If you look back here at the bottom, I've got B squared and A squared here. I think I'm solving for A squared, so these should be backwards. All right, so I want to find for A squared. I want to find what A is first. So it's going to be L squared, take away A squared, take away B squared, is going to equal A squared. So moving over here, here's my question, my formula. Here's my substitution. 85 squared, that's my hypotenuse, or along the side, and there is the length B. So this is 7,225, take away 4,900. That gives you 2,325. And of course, the square root of the square root of A squared is A, and the square root of 2325 is 48.218. Now that I know that, I can round it off, because in the instructions here, if you look back, it says to round it off to the nearest centimeter. You have to read very carefully here. Okay, nearest centimeter, that's what it says right there. So having done that, I now have 48 centimeters. So now that I know that A is 48 centimeters, right, I know the distance from here to here is 48. I know this is 85, so to find this, I've just got to take OC, which is 85, and subtract the length that we got for OD, and that was 48. So here we go. So there's our solution. DC is equal to OC, take away OD, put the numbers in, and we find out that the depth of the water is 37 centimeters. Okay, so that's a typo. And don't forget your units, centimeters. Okay, here's the next one. A chord is 8 centimeters long. So what you're going to have to do here is, this one's on you. I want you to put in all the information and solve this, and then we'll go over it together. So pause the recording and do that. Okay, so it says here a chord is 8 centimeters long. So I'm going to go here. Here's my chord. That's 8 centimeters long. Now the moment we're working with these pictures that have a bisector, right, we know that this and this are equal. So guess what that makes this one right here? That is 4, and that's 4. Okay, so we now know what these two numbers are right here, because we know that these two things here, this side here and this side here, are equal. We also know that's 90 degrees because this is a perpendicular bisector. All right. Now it says here, what is the radius? I don't know what the radius is, but we do know that a radius, we've drawn them in. The radius is going to go from here to there, or from here to there. So now I have a right angled triangle, and this here length is 12. This length is 4, and I want to find the hypotenuse. Now the hypotenuse is from the center out to here. It's the longest side. So the radius is the distance you have to from the, oh sorry, I've already got that in there, so don't worry about that. So here we go. L squared or H squared or C squared is equal to A squared plus B squared. Put in the 12, put in the 8. 12 squared is 144. 8 squared is 64. add them, 208, take a square root of L squared and the square root of 208, go back up to our question. It's the nearest tenth of a centimeter. So rounding this off to the 4, the 2 does not cause the 4 to change. So that means my length of my hypotenuse is 14.4. So there is 14.4. So go back over these, redo them as many times as you need to until you can do them without any difficulty. And we will see you in the next lesson.